Hello and welcome to Week 2, Chapter 2, Remote Instructor Training Overview. Chapter 2, Sections and Objectives. You should read Chapter 2, review this video, complete the required labs and lab reflections, and take the Chapter 2 exam before continuing on to the next chapter. Chapter 2 Lab Overview. Setting up the Arduino IDE application. Time to complete is approximately 30 minutes. Difficulty level is easy. Follow the instructions in the 2.0.0.0 Arduino IDE software installation document in the Arduino software folder or in the 2.2.2.5 lab for help setting up the Arduino IDE application. These documents will detail the setup, configuration, and testing of the Arduino environment. Read carefully, setup can be tricky. Examine the port configuration in the bottom right corner of the Arduino IDE to help troubleshoot connection issues. You should get a successful test before continuing on to the labs. Troubleshoot as needed. Lab 2.2.2.5 Blinking a LED using Arduino. Time to complete is approximately 20 minutes. Difficulty level easy. Build the basic circuit following the schematic, fritzing diagram or written wiring instructions. Students need to be able to understand all three. When in doubt, always follow the wiring schematic. Looking at the diagrams, pin 13 on the red board Arduino connects to the 330 ohm resistor. The other end of the resistor connects to the anode or positive terminal of the LED. The cathode or negative terminal of the LED connects to the ground wire connected to the ground pin on the red board Arduino, completing the circuit. This is the completed version of the 2.2.2.5 lab. Open the Arduino IDE and load the 2.2.2.5 Blink a LED sketch in the 00.IoT Connecting Things example folder. When you click on the upload icon in the Arduino IDE, watch the bottom of the screen for an indication of what's happening as the sketch is compiled and uploaded to the red board. Watch the TX and RX indicator lights rapidly flash as you upload the sketch. Then the LED and pin 13 will flash in 1-second increments. You can extend this lab by changing the code to make the light flash at different intervals. Troubleshooting steps to keep in mind: sketch not loading correctly, bad LED, wiring issues, or the LED being backwards will keep the lab from working correctly. Lab 2.2.2.6 RGB LED using Arduino. Time to complete is approximately 30 minutes. Difficulty level easy. Wire the circuit as shown in the diagram. Note there are separate wires for each color for the LED and a single ground. This is the completed version of the 2.2.2.6 lab. Blink the RGB LED using the 2.2.2.6 sketch in the 00.IoT Connecting Things example folder. When you click on the upload icon in the Arduino IDE, watch the bottom of the screen for an indication of what's happening as the sketch is compiled and uploaded to the red board. Watch the TX and RX indicator lights rapidly flash as you upload the sketch. The red, green, and blue lights should change at 1-second intervals with a 1-second pause at the end. Troubleshooting: double-check the wiring if the LED doesn't flash correctly. Wrong resistors, bad LEDs, and miswiring will also cause most issues. Lab 2.2.3.2 Photo Resistor. Time to complete is approximately 45 minutes. Difficulty level intermediate. The objective of this project is to use the photoresistor to change the brightness of the LED. This lab is slightly more complex because two separate circuits are involved. One for the photoresistor and one for the LED. Using the schematic, The positive 5 volts passes through the 10k ohm resistor and photoresistor before returning back to ground. The wire reading the light level value is placed between the resistor and photoresistor. The sensor value is read through the analog 0 pin. The LED circuit is the same as the previous project with the value coming from pin 9. This is the completed version of the 2.2.3.2 lab. Vary the intensity of the LED using a photoresistor and the 2.2.3.2 sketch in the 00.IoT connecting things example folder. Note: use something like the cap of a black pen to cover the photoresistor to ensure maximum variance in ambient light. You will have to play with the light level setting to ensure the maximum range and intensity of the photoresistor and LED. Use the serial monitor to read the photoresistor's values. Watch the serial monitor for a few seconds to see what its lowest value is. This value will replace the 0 in the calibrated light level line of code. Then cover the photoresistor and watch the serial monitor for a few seconds to see what its highest value is. This value will replace the 1023 in the calibrated light level line of code. You will have to upload the sketch again for these changes to take effect. Extend this lab by changing the code to make a night light. Comment out the analog right LED pin calibrated light level line of code and uncomment the digital night light line of code. Troubleshooting steps to keep in mind. Sketch not loading correctly, bad components, wiring issues, LED is backwards, or the sensitivity of the photoresistor or LED conversion needs to be adjusted. Lab 2.2.4.2 Potentiometer or Flex Sensor and Servo. Time to complete is approximately 30 minutes. Difficulty level intermediate. The objective is to use the potentiometer to rotate the servo. Using the schematic, the 5-volt wire connects through the potentiometer and back to ground using the 2 outside pins. The potentiometer's value connects to the center pin and back to the analog 0 pin. The servo connects to the 5-volt and ground connectors with the servo position value wire connecting to pin 9. This is the completed version of the 2.2.4.2 lab. Rotate the servo using the potentiometer and by using the 2.2.4.2 sketch in the 00.IoT connecting things example folder. You will have to play with the setting of the potentiometer to ensure the maximum range of the servo. Use the serial monitor to read the potentiometer's minimum and maximum position values and adjust the map flex position line of code accordingly. The servo should turn approximately 180 degrees to match the potentiometer. If you are using the flex sensor, be careful to hold the sensor near the bottom to ensure the connectors don't break. I changed the lab to a potentiometer for this reason. Troubleshooting steps to keep in mind. Sketch not loading correctly, wiring issues, bad components or the sensitivity of the photoresistor or servo conversion needs to be adjusted. Lab 2.2.4.3 Relay. Time to complete is approximately 60 minutes. Difficulty level difficult. The objective of this lab is to make 2 LEDs alternate using a relay and transistor. Carefully place the components and wires according to the schematic. There are basically 3 circuits being used, one for the LEDs, one for the transistor and one for the relay. The transistor signals the relay to energize an electromagnet that changes a contact from green to red, thus changing the LEDs. I have not found a single pole double throw relay that fits onto the breadboard correctly. I pre-solder short solid core lead wires onto each of the 5 terminals of the relay to facilitate connecting it to the breadboard. This is the completed version of the 2.2.4.3 lab. Make 2 LEDs alternate using a relay and transistor using the 2.2.4.3 sketch in the 00.IoT Connecting Things example folder. Troubleshooting steps to keep in mind. A sketch not loading correctly, wiring issues, bad components or the diode and transistor being connected backwards can cause project failure. (2.3.1.2) Sensors and the PT Microcontroller Packet Tracer Lab. Time to complete is approximately 30 minutes. Difficulty level intermediate. The objective of this lab is to use the microcontroller unit, MCU, to manipulate several different components. Remember, a microcontroller unit is really an Arduino. You will complete these labs and reflections during week 2 of your training. If you have any questions, please feel free to contact me.